Okay, today we're going to look at equilateral triangles and drawing them versus constructing them. And you might think of that as being the same thing, but in geometry it's very different. We could draw something that looks equilateral, or we could actually construct something to be equilateral, and there is a difference. But at first glance, if we look at these shapes, these both appear to be equilateral triangles. One of the things we can do in Sketchpad is measure each of the lengths. So I'm going to measure each of the lengths of this first triangle. I'm going to move them down here. And we see that each side is 3.1. So it looks like triangle ABC is equilateral. I'm going to do the same thing with the sides of triangle DEF. And I'm going to measure their lengths. And they get put right below the other three. But I'm going to move it over here so we can clearly see which one is which. And we can see these are also 3.1. So we have kind of like identical looking triangles here, different vertices. You might even say that they're congruent. But in terms of construction, let's see what happens if we move one of the vertices around. So let's take vertex C. Just gonna, well, that doesn't do anything. It moves the whole thing. So that doesn't change anything. But let's look at vertex A. Now the equilateral triangle sides get bigger, but they're still, all the sides are still the same. Okay, we can drag this in here, go back to where it was, everything. So this, we've constructed this to be equilateral. But if we go over to triangle DEF, let's see what happens here. Uh-oh. This was a triangle that just looked equilateral. But if we drag the vertices around, they are not, in fact, equilateral. All right, so that's the difference in Sketchpad between sketching and just drawing something that looks equilateral. So we made it that both of them looked equilateral, but only one of them stays equilateral, and that's the one that's been constructed properly. So let's look at how we actually do that. So we're going to go to another page. So that was the intro page. Let's go to the construction page, and let's make one from scratch. So we're going to take a segment, any old segment, and we have to find the point up here, kind of where the cursor is, so that it is equally far from where my cursor is to each of these endpoints. I'll just name the endpoints now. You can see we've got, that's a G and that's an H. Okay, so we have G and H here. So the way we're going to do this is we're going to use the circle tool. So the circle tool, we're going to draw a circle that's centered at G that passes through H. And it goes off our screen a little bit, but that's okay. And then we're going to, let's look this at the circle. Every point that's on the green is the same distance from G as H is. So now we're going to do the same thing, but we're going to center it at H. And we're going to come over here, and now we have a circle that passes through G, centered at H. And where do you think that key point is? Remember, I was pointing up here, and it's certainly here, the point that these two circles intersect at. Because if we put a point there, we'll see this point is on both of these green circles. So that means they're equally far from G as they are from H. So all we have to do is draw back to each of our original vertices. We can name our point I. To clear up the picture, I'm going to hide these circles. So I'm going to select both of them at the same time. Now I could go to display and just hide the circles, but that's kind of a permanent solution. Or once they're hidden, you have to show all the hidden objects. So if I want to maybe bring them back in the future and have control over it, instead of hiding the circles, I'm going to go to the Edit drop-down and select Action Buttons. And come over to Hide Show. And now I'm going to have a button that can hide the circles and show the circles. Hide the circles, show the circles. So I'm going to leave them off for right now. And the last thing, to verify that we have an right triangle, an equilateral triangle, is let's select each of the sides and measure the lengths. We can see that they're all 5.9. But the real test is, can we move the vertices and it stays equilateral? So we're going to go like this. They're 1.8. Around here they're 7.7. So it looks like we've successfully done it. And the key step here, and I'll show these circles just to bring this back, is drawing these green circles that are centered at each of the two original endpoints and pass through the other respective endpoint. And where they cross is where the point we should select to be the third vertex of our triangle, of our equilateral triangle. Notice we could have picked the point down here and it would have worked just as well. But I like the one up here, and we're all set. So that is constructing the equilateral triangle.